So 9.5 number 3 looks like this. What do we do? Okay, so I'm trying to solve, right? So I could find a common bottom for everything here. Do I need to do that? Oh, okay. So here's the common bottom I would kind of be looking for, right? Let's see. Yeah. Do I need to do that? No. Don't bother. You're solving, right?
Right.
Here I have an equation, right? Left-hand side equals right-hand side. Right? Just like when I'm doing something like x over 3 plus x over 5 equals x over 7. I don't bother finding a common denominator, right? I just blast the bottoms out of the way by multiplying by, well, let's see, 3 times 5 times 7. Does that make sense? Do you find a common bottom to solve these? How do you solve these? We do this?
Kidding. So it has to be 15 times 7? That's the denominator?
Yeah, but just do it in pieces, right? Multiply by 3, maybe? What do you get?
Can't even know.
Get 3 times the left-hand side, right? Equals 3 times the right-hand side.
Okay.
But 21 doesn't go into 5.
No, which is why I'm going to have to multiply by 3 times 5 times 7.
Oh, wow.
Right? And if I was trying to find a common bottom here, that would suck.
Right.
But just multiply by the pieces. So you multiply by 3, distribute the 3 in, right? You'll get 3 times x over 3 plus 3 times x over 5 is 3 times x over 7. Right? Just scary because there are lots of fractions, right? But what cancels? The 3's cancel.
You already did it. Why are you doing it again?
I already did it.
So we just
I don't
keep
know what
going
you-
until we cancel each one out.
Yeah, really. So here I've got an x plus 3x over 5 is 3x over 7, right? Now I'm in a better place because I have one less fraction than I started with. So if I want one less fraction than this, how do I do it?
Solve for x. No?
Yeah, multiply by 7 or 5. You guys see that? That'll clear the bottom. If I multiply by, say, 5, I'm going to get 5 times the left-hand side. Is 5 times the right-hand side. All right, so then I'm going to distribute. I'm going to get 5x plus
15x over 5.
5 times 3x over 5. Don't bother multiplying it out because it's going to cancel. And then on the right-hand side, what do I get?
3x. No, 15 or 3 times 5.
15x over 7 or 3 times 5 times x over 7. See, now I'm in a better place yet, right? Because now I've got, oh, this is 5x plus 3x, right?
8x.
Which is 8x. And that's 15x over 7, right? So now I multiply each side by 7. You guys get the gist? Okay, so this is really how I want to try to solve. Just blast the bottoms out of the way. Don't bother, yeah. You can blast each piece, or we could have noticed here the common bottom was 3 times 5 times 7, right? If I had just multiplied all this thing times 3 times 5 times 7, right? Multiply both sides by 3 times 5 by 7. 3 times 5 times 7, everything would cancel.
So you don't do,
You can do it step by step, or you can do it all at once. It's your choice.
so if I want to put 15 times 7,
Mhm.
that's everything.
Yeah,
It's
and
okay.
then all the bottoms will cancel, right? And then I'll be left with a equation with kind of integers, right? Something easy to deal with. So do the same thing here. instead of bothering to find a common bottom, just multiply by the pieces.
That's huge. Thank you.
So if we take this guy, what are the pieces of the common bottom? 2y plus 3 is one of the pieces, right? So let me multiply by 2y plus 3. So if I multiply both sides by 2y plus 3, let's see. I get 2y plus 3 times this whole right-hand side. Equals 2y plus 3. I said right hand side, that's still the left. So I get 2y plus 3 times the left equals 2y plus 3 times the right. Yeah? Then I should what?
Cancel. No? Oh.
So then I should distribute first. I'll do the multiply by the other thing next. But distribute first.
I would cancel.
Yeah, there's a lot of potential for false cancel here, which makes remember to distribute important, right? But I distribute, I get 2y plus 3 times this left thing, 3y over 2y plus 3 times 3y minus 2 minus 2y plus 3 times 7 over 2y plus 3. And it's going to be equal to this stuff. So there's a 2y plus 3 times a y minus 1 over 3y minus 2.
You just got it. Oh, no, you didn't. Sorry.
Yeah, I didn't quite copy the line above, right? I put this on each of these. Okay, see that? Okay, now what?
Cancel.
Cancel. What can I cancel?
2y plus 3
Where?
on the first one.
Okay, so there's a 2y plus 3 times a fraction with a 2y plus 3 in the bottom. Okay, so I can cancel those. Can I get another one?
The second.
Cool. So in multiplying by 2y plus 3, what happened? Well, all the fractions with a 2y plus 3 on the bottom lost it. And the one that didn't have one on the bottom got one in the top. You guys see that? I'm trading having all the 2y plus 3s on the bottom for having some 2y plus 3s in the top. It's just a trade-off. Okay? So then, let's see.
3y.
So this is just a rewrite, there's nothing here. So if I rewrite, I've got a 3y over what? 3y minus 2
minus 7.
7 equals
2y plus
2y plus 3 times
1 minus
y minus 1 over 3y minus 2.
Okay.
Okay, now what? Yeah, I want to get the 3y minus 2's out of the bottom, so let me multiply by 3y minus 2. Again, this is trading, right? I'm going to trade 3y minus 2's in the bottom for 3y minus 2's in the top. You guys see that? So these two are going to go away, and I'm going to get one there. We can do that all in pieces. So I've got 3y minus 2 times the left-hand side stuff equals 3y minus 2 times the right-hand side stuff then I need to distribute again. Again, this being crucial. Okay. So I get a, don't do that.
That's exactly what I was gonna do.
So I got a 3y minus 2 times a 3y over 3y minus 2. Right? That's this thing times the first one. Then there's a minus 7 times this guy. And then on the right-hand side, there's, can I do something on the right-hand side?
Yeah.
What can I do on the right? I can cancel the 3y minus 2's. I didn't need to distribute there. So really, there's also and cancel here. So on the right-hand side, I end up with a 2y plus 3 times a y minus 1. What else can I do on the left-hand side? There's 3y minus 2 top and bottom, so I can cancel those guys. All right, so this step is a cancel step. So I get a 3y minus 7 times 3y minus 2 is 2y plus 3 times y minus 1. Okay, see that? So really, I could look back at the beginning and see that. I've got both pieces of the common bottom here under this guy. So that one's top is going to be inherited by the end. Okay, see that? I got a 3y on top here. I got a 3y on the left-hand end there. What happened to the 7? Yeah, to get the common bottom here, it needed a 3y minus 2, right? So it got one at the end. I traded the 3y minus 2 it was missing in the bottom for one on the top at the end. This guy was missing a 2y plus 3, and the only tricky thing is that I have to remember to multiply the whole top by that 2y minus 3. Plus 3. 2y plus 3. See that? If you went through all the trouble to find the common bottom here, what you would get is exactly this stuff, but it would be all over the common bottom on the left-hand side, all over the common bottom on the right-hand side.
So it's better to do it that way. The way
So,
I don't know, it's different.
so in my wording, I want to say, instead of finding the common bottom, we want to multiply across.
Yeah, we want to multiply the whole equation by the common bottom. You guys see that? If we had multiplied this whole equation by this thing times, we could have multiplied by these two together, and then the canceling would have all happened in one step.
But we don't want to do that.
You can if you want. This is more steps. Some of you are more likely to get it right if you do it in 2 steps. Some of you are more likely to get it right if you do it in 1. I don't care which one you do. Practice, figure out which one works better for you. I personally look at things like this and say, okay, what am I missing here? What am I missing here? What am I missing here? And then just put them in. But that's because I've done a million of these. Okay? So practice, practice. You'll see the pattern. You can check the pattern when you get to the end. Like, oh, the 3y was over the common bottom. Yep. The 7 was missing a 3y minus 2. The y minus 1, that thing was missing a 2y plus 3. You guys see that? Okay, am I done with this problem? No, but now I've got it in a form I know how to deal with, right? I got out of scary fraction land into something else land. What's the something else land I'm probably in?
3y minus 21.
Okay, so I should distribute. So this is, maybe instead of distribute, I would write multiply it out. Right, so we multiply all this junk out. So we've got a 3y minus
21.
21y plus 14. I'm liking that, Jennifer. Thank you. Equals 2y squared minus 2y plus 3y minus 3. Anybody mystified by the FOIL here? None of you? Good. Okay. Surprised, I guess? Yeah, multiply it out is leave this guy alone, distribute this guy, FOIL that stuff, right?
Okay.
So it's gonna take a bunch of different forms, but largely it's gonna be distribute, FOIL, then what? Yeah, so next step is gonna be this combine like terms. Okay, so let's see, what can I combine right now?
You can get out on the other side, the twos are out. Oh, no, sorry. Leave it there.
Let's see, so here I can get the y's together, right? So I've got minus 18y plus 14 equals
2y squared.
2y squared.
Minus 1.
Is it plus or minus, guys?
Oh, plus 5.
Plus, good.
Minus 3.
Minus 3. Okay, what kind of problem am I in? Yeah, so I could know here, right, that I'm in quadratic land. Right? So now I get to choose what my quadratic method is.
Is quad land Montana?
No. This is somewhere in Greece. Wow. This is someplace in Greece, quadland. I think so.
I like to factor.
So what do I do now? Can't. Maybe. We can try. So we can get it all set equal to 0 and then try to factor. It doesn't do us any good to factor kind of both sides, right? We need to have it set equal to 0 to apply the 0 product rule. Okay, so what am I applying? Which side do I want to move stuff to?
Minus 2y.
Okay, so I'm applying add 18y, subtract 14 to both sides. So that's going to leave me with 0 is, I got a 2y squared. How many y's? 19. And minus 17. Okay. So now what do I do with this? We could cram this in the quadratic formula. We could try to factor.
No, you can't factor that number.
Or we could what?
No.
It's not a difference of squares.
It's just.
Wait, I'm sorry.
Yeah, so which thing are you good at?
Factor.
Are you good at factoring? Are you good at the quadratic formula? Are you good at completing the square? Anybody want to complete the square with this one?
No.
No. Good. Okay, good eye, right? I don't want to complete the square both because there's a 2 here and because that's not divisible by 2. Right? Okay, so complete the square is out as a method, so...
Quadratic.
Okay, so...
Excuse me, I'm sorry, I don't understand that part, I'm sorry. Those 18 minus 14, what did you do?
I'm trying to get rid of this stuff, right? So
you
I...
just changed the sign.
No, so I added 18y to get rid of the minus the 18y, and I subtracted 14 to get rid of this. I did that to both sides, which is why I ended up with y plus 18y is 19y on the right, and minus 3 minus 14 is minus
Can you
17.
write it on the other side so I understand?
Sure. Okay.
Thank you, I'm sorry.
Yeah, so when I'm doing these arrows, I mean, this is the thing I'm doing to the whole equation, right?